My name is Emma Doring, and this is my Physics 2211 Lab 4 on oscillations. Here's just an agenda of what I'll be going through. So the purpose of this lab was to analyze the motion of a spring mass system while the spring oscillated vertically and swung in an arc, and then compare its predicted motion in GlowScript to its observed motion in Tracker. The models and fundamental principles I used the kinetic energy formula, gravitational potential energy, spring potential energy, the energy principle, gravitational force near Earth's surface, spring force, velocity update formula, position update formula, and Newton's second law. And all the energy formulas were used to find the overall change in energy of the system, and then Newton's second law and the position and velocity update formulas were used to find the position data for the system, and then the gravitational force near Earth's surface and the spring force were used to find the net force on the system. A preview of my results. So I found that the predicted position data from GlowScript was pretty similar to the observed position data from Tracker. The total change in energy for the system was 0, and then the change in gravitational potential energy was basically the opposite of the change in spring potential energy on the final graph. And then at the bottom is just the model of the spring mass system from GlowScript. The initial conditions: the system was the spring and the mass, the surroundings was everything else. Calibration length was 0.7 meters, the mass was 0.402 kilograms, initial position negative 0.118 in the x direction, negative 0.669 in the y direction meters, and then initial velocity was 0 meters per second, little g 9.8 meters per second squared. The spring constant was 6.83 newtons per meter. L naught was 0.123 meters, the initial time was 0 seconds, and then delta T was 1 over 210. The experiment details. So first I downloaded the spring mass video from Canvas and put it into Tracker. Then I calibrated the video and set the time frames. I tracked the mass's motion at each time step in Tracker, and then I copied and pasted the position data from Tracker into an Excel sheet. I opened the starter code in GlowScript, put the Excel file as a CSV file into the code, and then I put the initial conditions in. I used the code to calculate L, L hat, and S of the spring, as well as the kinetic, gravitational potential, spring potential, and total energy of the system, and then the net force using the spring and gravitational force. Then I updated the position, velocity, L, L hat, and S, and then finally calculated the change in energy type and in total energy of the system. And then there's just the original video. Okay, so the coding details. The first image shows all the force calculations on the system, as well as the velocity and position update calculations, and the L, L hat, and S update calculations, and then the energy changes of the system. And the second image shows the calculations originally of L, L hat, S, and each of the energies of the system. So the final results, on the left you can see is the change in energy versus time graph from GlowScript, and the yellowish orange horizontal line is the total change in energy. You can see that that's 0, and then the rest of the energies are kind of just oscillating. And then on the right we have the comparison of the X position from GlowScript and the X position from Tracker, as well as the Y positions. Red is Tracker and blue is GlowScript. So you can see that the X positions for GlowScript and Tracker are pretty similar, but then for the Y positions they differ more, and I'll go into the sources of error next. So some sources of error that could have possibly happened: human error when I was tracking the center of mass in Tracker, coding errors, GlowScript reading the CSV file wrong, non-number characters being in the Excel table, and then a poor delta T chosen. Finally, my additional questions for the model system: is the energy principle satisfied? I said yes, the energy principle is satisfied for my model system because the total change in energy of the system is 0, and this matches the fact that there's no work being done on the system or thermal energy coming into or out of the system. And then the second part, I calculated an oscillation period estimate for both the x position and the y position. For the x position, I got t equals 1.53 seconds, and then for the y position, I got t equals 1.43 seconds. These two period estimates are about 0.1 seconds off, which is probably due to either a tracking error or another error that I mentioned previously. That's all. Thank you for watching.